This is the video lesson for determining initial velocity components. The learning target for this lesson is, I am learning to calculate the horizontal and vertical velocity components of a projectile using trigonometric functions. The success criteria for this lesson are, I can separate a velocity vector into its vertical and horizontal components, I can calculate the vertical velocity using the sine function, and I can calculate the horizontal velocity using the cosine function. All right, so far in this unit, we've been given velocity vectors in their components. So we've been given an initial vertical velocity and an initial horizontal velocity. But often in a problem on projectile motion, we'll be given just a composite vertical or composite velocity. So like in this example, we have a initial velocity of 60 meters per second at an angle of 35 degrees. And we'll need to break that velocity vector up into its components. So to do that, we're going to do some steps that I outline in this video. So let's look at this vector broken up into its y velocity component and its x velocity component. So right now we have a velocity vector of 60 meters per second, and this is an initial velocity, and we want to know what is the vertical velocity component and what is the horizontal velocity component. But right now we don't know those, so these are question marks. And in this video we're going to talk about how you figure out what the velocity component is in the y direction and what the velocity component is in the x direction. All right, so let's look at how to determine the vertical velocity component. So first we have our just composite velocity. So we have v naught is equal to 60 meters per second. So that's this composite vector here. So it's not a vertical vector, it's not a horizontal vector, it's this composite vector, and it has an angle of 35 degrees. So we want to know the vertical velocity component. So we want to know v naught y. We want to figure out what is this part of this velocity vector. So to figure that out, we're going to use this equation. So we have v naught y is equal to v naught. So this is v naught y is the vertical velocity component. V naught is the original composite velocity, and then sine of theta is going to give us the part of the part of the composite velocity that is just in the vertical direction. So notice that our vertical component of the velocity in combination with the composite velocity makes a right triangle, which is why we're able to use the sine function here. So if we put all this together using the composite velocity that we have here, 60 meters per second, so our vertical velocity component is equal to 60 meters per second times sine of 35. That equals 34.4 meters per second. Now in a similar fashion, we're going to determine the horizontal velocity component. So our original velocity, our composite velocity vector is 60 meters per second. Now we've got our component, horizontal velocity component. It's in the x direction, and we don't know what that is. So our formula for the x component of the horizontal, so the x component of our velocity vector is going to be v naught times cosine theta. And if we look at it all together, we see 60 meters per second times cosine of 35 is equal to 49.1 meters per second. So our v naught x, or our horizontal velocity component, is equal to 49.1 meters per second. All right, we're going to do a couple of examples here. So example number 1, finding the horizontal and vertical velocity components. So we've got a free throw shot by a 6-foot tall player at an angle of 50 degrees from the floor with an initial velocity of 6.7 meters per second. We want to know the initial vertical velocity and the initial horizontal velocity. So for our initial vertical velocity, we're going to do 6.7 meters per second times sine of 50 degrees. And that's going to give us a vertical component of 5.1 meters per second. And then in the x direction, we're going to have 6.7 meters per second times cosine of 50 degrees. That's going to give us a horizontal component of velocity, 4.3 meters per second. All right, example number 2, a cannonball is launched from an antique cannon during a Revolutionary War reenactment at an angle of 48 degrees from the horizontal with an initial velocity of 33 meters per second. We want to know what is the initial vertical velocity and what is the initial horizontal velocity. All right, looking at our equation here, we have V naught in the y direction is equal to our composite velocity, which is 33 meters per second, times the sine of our angle, which is 48 degrees. That's going to equal 24.5 meters per second for our initial vertical velocity. And then for our initial horizontal velocity, we have 33 meters per second times cosine of 48 degrees. And that's going to give us an initial horizontal velocity of 22.1 meters per second. All right, keep asking questions, everyone. It's how you learn new things.